Hi students, Professor Nugent here. In this video, we're going to briefly discuss polynomials. Polynomials are a way to reflect a nonlinear relationship using a polynomial up to order q. So we'll have a regression equation, y equals beta naught plus beta 1 times x plus beta 2 times x squared all the way through beta q times x to the power of q. And we can, of course, include other explanatory variables other than x. Here we have just a simple example. I have in this diagram an example of a production function that demonstrates diminishing marginal returns, and one way to reflect diminishing marginal returns is using a polynomial regression function. The interpretation of a polynomial can be completed two different ways. First, for a change in x from an initial value to an ending value, we calculate y for the ending value and subtract y for the initial value, right? So you get a predicted value where x is equal to the ending value, and a predicted value for y where x is equal to the initial value. You take the difference, and the difference in the predicted values for y is, in effect, the partial effect of x on y for the change in x. So that's one way, and the most accurate way to get the interpretation for the effect of x on y. Another way to do this is to use a differential approximation. Okay. If we use a differential approximation, say we have a polynomial of order 2, so that y equals beta naught plus beta 1 x plus beta 2 x squared plus u. I'm just looking at a very simple example, assuming that x is the only explanatory variable. Then the derivative of y with respect to x is equal to beta 1 plus 2 beta 2 x. Now, this line reflects the fact that the change in y with respect to x depends on the value of x. So the partial effect depends on the value of x, right? The partial effect is not constant. The smaller is x, the smaller is going to be the partial effect. The larger is x, the larger is going to be the partial effect. Now, typically, we may use something like x bar to interpret what the effect of x is on y, and that's going to give us our average partial effect. Okay, or you may use some other value for x that is of interest for interpretation. Another example of a polynomial then might be a cost function, which is typically a polynomial of order up to 3. I'll write this up here, which is beta naught plus beta 1 x plus beta 2 x squared plus beta 3 x to the third. And so x is quantity, right? Cost is on the y-axis. And what you might see is, if it's a polynomial of order 3, you might see something like this. This may be potentially or an exaggerated version of the polynomial of order 3. All right, so that's it for polynomials. Stay tuned to the next video. We are going to discuss interaction terms.